Thank you very much for coming. So I want to talk today about Angular 2, and some of you might be wondering, what's Angular 2 anyway? That's a joke, because I'm guessing probably most of you, if you've been rotating in Angular circles, you probably have by now heard of Angular 2 quite a bit, but at the same time, I imagine that for a lot of people, what exactly it is might be still a little murky. And then more importantly, what should you be doing about this? And that's going to be the topic of today's talk. So what is Angular 2? Well, first of all, Angular 2 is, I think, probably best described as a new front-end framework inspired by Angular 1.x, right? I think that if you're going to be thinking about this as a next version of Angular, as if it was, Angular 1.4, Angular 1.5, you would be probably a little bit surprised, maybe bewildered by how different it really is, right? But it's called Angular 2 for a reason. It really is in many ways a new framework. Now, at the same time, it does show a lot of there's a lot of things that it inherits from Angular 1, and I think you could think of, in some ways, what the authors tried to do is take what they thought, obviously, was the best parts of Angular 1x, and what actually aligns with what we think are the best. Now, they didn't necessarily come and ask me personally, but I was really excited about a lot of their choices, because it seems to me that the things that actually are continued from one framework to the other are actually the best parts of it. Now, at the same time, I think to understand Angular 2, we also need to consider all of the other things that it's actually inspired by. And it's not just Angular 1.x. It's not, it didn't develop in a vacuum just as a reaction of our experience with 1x. It really draws on a whole bunch of other things. And that's something that I'm going to talk about today, talk about quite a bit. Now, finally, Angular 2 is now in alpha. And what this practically means that you could, strictly speaking, run it, but it's a painful process. So because of that, when we were initially planning this talk in March, I was thinking that, well, maybe this is going to be more of a build your first Angular 2 application kind of thing. I don't think it necessarily at this point, as of end of April, really quite makes sense to do that, because the current state of Angular 2 is that the code seems to be fairly stable, but the documentation is close to non-existent. Now, up until recently, there was a big announcement at NGConf in March that the docs are going to be available in Angular.io. For the longest time, there was nothing there at all. Now, you do find there was recently a sort of a drop of documentation, but the documentation is very bare bones. So, if you want to go ahead and start building an Angular 2 application today, you kind of need to get ready for some pain. And one of those, I'll talk about some of the specific sources of that pain. So because of that, I am not going to focus so much on how to build your first Angular 2 application, because I think it's a little early for this. I'm guessing that the more adventurous among ourselves will probably want to start seriously thinking of building Angular applications for the more sort of forward-looking projects, maybe end of summer. I'm guessing for a lot of people, it's going to be more like the end of the year. But what I want to focus today is kind of laying out understanding what is Angular 2 and why it is the way it is, and kind of providing a little bit of a landscape so that you could think about it. And then also talking a bit about what are the things that make sense to do now. Between now and the time that when you actually really would want to start adopting Angular 2, which would probably be closer to the end of this year. So you've got 6 months, 7 months before that potentially. We want to also know what are we going to do. So this is going to be sort of the end of this talk. So first, let's talk a bit about the context. The context within which I think Angular 2 becomes a lot easier to understand. So one influence on Angular 2 is obviously Angular 1.x, and in particular, all of the different challenges that I think the community has encountered with Angular 1.x. I think it's fair to say that there are lots of things in 1x that are great and that are being carried over, but there's lots of things that seem like a good idea initially, but in retrospect, a lot of us have realized that they bring lots of downsides. Now, the second influence on Angular, the second part of the context is the sort of rise of components, right? So it's kind of the more componentized approach to web development, front-end web development, which has sort of appeared in a number of ways, but there's two kind of most prominent ones that are probably most visible. One is web components are kind of slowly edging towards becoming reality, and the second one is React.js. React.js have really brought for a lot of people sort of the message that you could actually build your application as a bunch of really independent components. So that's one thing. The second thing that I think that to which Angular 2 in a way reacts is reactive programming. So reactive programming, again, is exemplified by React.js, by Flux architecture, by the sort of growing popularity of functional reactive programming. And I think in some ways, Angular 2 demonstrates some of those kind of sensibilities. Then the fourth influence, of course, is the growth of ES6. Right? I mean, so at the time when Angular 1 came out, ES6 was barely on the horizon. Now ES6 is pretty close to reality, and ES6 provides alternative solution to a number of problems that Angular 1 tries to fix sort of its own way. And in particular, one of the things that from ES6 that end up being very influential in Angular 2 is classes. Those end up being used fairly heavily, and annotations. Now, annotations are sort of there in a funny way. I mean, they're not really ES6 annotations because ES6 doesn't include annotations. But they do end up being a fairly powerful extension of ES6 classes, and that's another thing that's leveraged fairly heavily in Angular 2. But in a way, you could think of that one of the reasons that Angular 2 is the way it is because there is today an opportunity to use those technologies. Right? There's a realistic opportunity. And then finally, strong typing. So strong typing, actually no, it's not final, there's one more. Strong typing has also, so JavaScript obviously naturally as a language doesn't have, has weak typing, but many people have found that as you work on larger projects, strong typing can help. Now this has been popularized through TypeScript as one popular solution, and that's the one that Angular draws on most clearly. Facebook's Flow was another one, but in general, I think it's fair to say that strong typing has been growing in popularity, including in functional context, and Angular 2 in some ways is a response to that. Then finally, ES6 modules. I'll talk briefly about Angular modules. I mean, Angular modules in 1.x are really kind of a bit fake. They're not here nor there. ES6 now provides us with full-on module solution, and again, Angular 2 ends up embracing that. So what I'm going to now do is I'm going to talk a bit about the first three items together. The reason I'll talk about them together because they are actually fairly intertwined, and then I'll talk about the remaining three briefly. So let's talk about the view and the event system in Angular 1 and Angular 2. So let's think a little bit about what did Angular 1x actually give us? I mean, so we say it's a framework, it solves presumably some of our problems, but what specifically does it offer? And I would argue that there is really, in a way, three things. And the first of all is the view synchronization system, right? So Angular gives us a method for having the view kind of automatically updated based on us just manipulating JavaScript objects, right? So that's very exciting because we don't end up having to interact with DOM directly. Instead, we have our objects, we modify it, and the view somehow reflects that. Then, in addition to that, Angular gave us modules with DI. Now, I think it's fair to say that in terms of modules, it didn't really give us all that much. On the other hand, DI, dependency injection, has been a very interesting and very powerful feature of Angular, and that's the one now that's, again, not available directly in ES6, but Angular 2 brings a variation on dependency injection, but now that would work with new features available in ES6 and TypeScript. And then finally, it gave us a bunch of utilities. Now, I mean, utilities like library for getting HTTP, making HTTP requests, and library for promises. Now, if you think about why Angular had to do all of that, though, you'll realize that the reason Angular has its own sort of utilities for things like that is because they're actually fairly closely tied into Angular's view synchronization system, right? And so as we move towards a different view synchronization system, we may potentially find that we don't really need to rely specifically on Angular methods for making HTTP requests or Angular promise libraries, and we have an opportunity then to move to native promise implementations, other HTTP solutions, and so on. But now, the view synchronization system, what do we actually find in Angular 1? Well, there's a couple of features of it, right? Especially when you compare it to some of the alternatives. One is that Angular's view synchronization system is highly declarative. There's a lot of things that you specify by providing configurations rather than by writing code, right? And this is not the same in all frameworks. The second is that it achieves a very high level of separation between templates and code, right? So you have your templates which look almost like HTML, and that someone with very little knowledge of JavaScript can actually edit. And on the other hand, you have your JavaScript that is almost entirely HTML-free, right? So now this is different, for instance, from jQuery code where it's sort of HTML and JavaScript kind of find itself meshing together, or from React.js code where this is also the case. Now in Angular, those are very cleanly separated. We ourselves have found that this is really a huge blessing on larger projects because you could combine very easily people with different strengths. You can have someone who is focusing on HTML and understands that piece really, really well. You can have other people working on JavaScript. They don't need to step on each other's feet quite as much because of this separation. So I would say those two things have been really great, for me at least, about the Angular's view synchronization system. Now, it also offered us two-way data binding, right? So two-way data binding basically means that we can actually have a component in our JavaScript. So we have an object in our JavaScript that is somehow magically bound to something in the view. And when it changes on one side, it changes on the other side. And this is kind of fun and magical. And I'm sure all of you remember those first Angular demos where they show you this, and it's like, wow, right? I think it's only later for a lot of us that we've started realizing that this actually is bad news, right? And I'll talk a little bit about this. Now, and the reason it's, well, one particular reason it's bad news is because this makes Angular's view synchronization very stateful, right? Ultimately, the view gets synchronized with the state of your plain JavaScript object, right? So what this means is Angular has to actually go and keep checking what's happening with that object, right? So this gives us two possible problems, right? One problem is that your object potentially changes and Angular didn't notice. And the other possibility is that Angular basically keeps checking things in a loop, right? And where, in particular, that becomes also problematic. And then finally, and this is probably we found to be the biggest issue, is that Angular arranges the state, the object representation of your UI, in this nested tree of scopes, right? And now this, again, on the first glance seems like a good idea because it makes it easy for your components to kind of just go ahead and communicate by modifying each other's data, right? But when you combine those two items together, the statefulness and the use of the nesting, that gives you a really dangerous combination, right? Because what this means is that you potentially can have, so you have a state on your hands that other components can modify kind of at will, and you don't really necessarily know who is modifying it, right? And this is where large Angular applications done this way can potentially be really hard to maintain. Now, we've found ways of sort of working around all of those things. I mean, we ourselves have been really overall happy with Angular, but I think it's fair to say that those three last issues have turned out to be a bit of a challenge with Angular. So now, let's talk about some alternatives. So there's alternatives. They're not really two different alternatives. You pick one or the other, but there's sort of two directions on which Angular's design has been challenged by sort of, let's say, competition. And one of them is components, right? So the alternative to Angular's sort of style has been, the idea has been to actually break your application into really small chunks. Now, Angular, as you will probably have realized, I mean, the services, you can actually do this with services. I mean, services in Angular can be broken up and very modular, right? But Angular design on the UI side encourages, especially, I mean, the documentation at some point did this very explicitly, encourages you to assemble your components into a tree, and which gives you a fairly monolithic application where every component can kind of relate to any other component. The alternatives, React.js gives us an alternative where components are sort of integrated in a more controlled way, where you just, if you have access to your children or your parent. And then web components has been another sort of idea here that has, again, offers you a much more limited interface. So the idea is that once you create a component, your component is enclosed as a black box, and it provides a very specific interface over which others can interact with it. And this makes your life potentially quite a bit easier. Now, in Angular, it's important to note, in Angular 1x, you can do this. You can do this using controller as, or you can do it using isolated directives, or especially you can do it by combining the two, by basically making isolated directives that then use controller as. This allows you to have a setup where you basically built a component that really no one can look inside of this component, and this component can't really look very far outside, except that you now need some kind of communication layer, and then oftentimes your services, which also contain your business logic, become that communication layer. Right? So you can do this with Angular, but I think it's fair to say, I mean, controller as was a bit of a late arrival, and there things there could be improved. Though again, no, if you have not yet adopted controller as, this is something that I really highly recommend. I mean, we now use controller as pretty much exclusively, and really just consider $scope anywhere in the code as just a sign of code smell. I think that we're just better off just pretending that $scope doesn't exist. And using controller as instead, where every component, every controller that you create basically has its own object that represents its state. And then isolating directives to achieve the same effect. Now, the second sort of dimension on which Angular's design has been challenged is the idea of, Angular's idea of two-way binding has been challenged by the idea of unidirectional data flow. Now, and this has been demonstrated by React.js, which focuses on the unidirectional flow, and which in particular gives it much better performance, right? Now, the interesting thing about React.js is that the way it does it seems unintuitive at first, right? Basically, every time something changes, React goes and regenerates the view, right? So you basically write a bunch of functions that just do it one way. But what this gives you, it gives you simplicity, and it gives you lots of opportunity for optimization, and the end result often has been that React.js solutions end up being faster. I mean, one of the things that we've sometimes found is that, well, it makes sense to build a larger application in Angular, but if you find a piece of the application where the performance is really an issue, sometimes it makes sense to actually drop React into that particular component, right? Now, but the reason for this gain in performance has a lot to do with this unidirectionality. Now, React does this in a particular way, which is very different from Angular. I mean, it's very procedural, and it merges HTML and code, right? So like once you basically cannot really quite tell where code ends and HTML begins. This is something that I personally find I like the Angular style a lot more, and this is where we would hope Angular 2 would provide us with, and it does. Now the second kind of illustration that comes from the same source, Facebook, is Flux architecture. So Flux architecture, the idea there is that you generally just try to avoid state altogether in your architecture, and instead of, the reason you want to avoid state is because every time you have state, you have the opportunity for missynchronization, where basically your view is in one state is showing one number while your service thinks it's a different number, and it basically because something failed to synchronize. Or it got synchronized, but it got synchronized in the wrong way, right? So this is kind of fundamentally the problem with two-way data binding, is that it's a little unpredictable. No, so with Flux, the key idea is that you focus on events rather than state, and you build your application as basically two pathways in the simplest case. There's a pathway that goes from, so on one end of your application, there is the view. View emits events, which is things that the user have done. And then on the other application, there is your business logic that is usually called the store in Flux architecture. So your user emits events, and you have a number of transformers which really ultimately convert one type of event into the other. But in an ideal situation, no one actually maintains any state until this gets into the store, and where the store is acts as the only source of truth, and that's where the data ends up being stored. Now, on the flip side, if something happens in the business logic of your application, for instance, new information got fetched from the server, or some other component has reported a change and therefore that has sort of propagated to your store, you now send events back on another pathway. And the important idea here is that those are two very different pathways, right? A pathway where you basically say, okay, this piece of data has got updated. And then this arrives to your view, and your view gets updated to reflect this latest change, right? Now, the important thing in this kind of architecture, your view does not maintain state, ideally. Your view is basically it's just basically marshalling events from the, potentially transforming them in the process, marshalling them from the view towards the store and from the store towards the view. This both ends up helping in terms of performance. It also helps, it makes it a lot easier to reason about complex data flows. So, and again, the key idea here is thinking in terms of events instead of thinking of state. I mean, an Angular 1x was very sort of stateful in that sense. And then finally, perhaps an even better way to do this is functional reactive programming. Now, functional reactive programming, I'm not going to sort of today try to sell you on this idea too much because it deserves its own talk. But the idea of functional reactive programming is that once you start thinking of your data in terms of events, if you think of those events as comprising a stream, you can start expressing operations on streams, right? So rather than instead of saying, every time, listen for this event, when this event happens, run the following code, you basically instead saying, well, let's map a stream, which is to say that you provide a mapping function. So it becomes kind of similar to the way libraries like Lodash or underscore do it, but instead of an array, you operate on a stream. So where you take a stream, you produce another stream. So this is something also that gets unlocked potentially with the unidirectional flow. So what does Angular 2 then promise us? Well, it's still very declarative, and this is one thing I like about it compared to looking at the solutions such as React. It's still very declarative, and it still separates HTML from JavaScript very cleanly. It now replaces what used to be Angular directives with 3 different things, and one of those is component. An Angular component really aims to match the semantics and behavior of a web component as closely as possible, and it's in the sense that it's a self-contained sort of black box where other components can't really reach into your, for that matter, DOM even very easily, and they really interact with your component through this very specific interface that your component defines. Now, it turns out that, and this is, I think, that when you work with Angular 2, most of what you're going to be doing is defining components. Components and services. Like most of your controllers and most of your directives will turn into components. Now, there's some cases where this doesn't quite work. There's certain directives that are really different in Angular, and one of those is decorators. So those are directives that don't carry their own template, but instead make some modifications. They act as a magic attribute that you attach to something. And then templates are Angular, sort of the equivalent of the more complicated directives that really do massive transformations. So, for instance, ngIf, it would be an example of such a thing, which really ends up actually changing your DOM. So depending on the condition, it either may put one thing or the other. But most of the kind of directives that most of us write will end up becoming components, and they end up being a lot closer to the way web components behave. Now, the third thing that Angular does is that it offers support for unidirectional data flow. Now, unfortunately, this is something that is being said loud and clear, but the documentation on this is still a little bit, is a bit less clear, and consequently, I'm not going to be providing a lot of examples of that, but this is the promise of that is very clear, right? So in the sense that you would be able to do so, and there's an element of unidirectional data flow that Angular just does. So it no longer allows you to just have any component listen on any other component state. Instead, you basically have a change propagation that is unidirectional, and but there's also an important element of this that Angular exposes to you as a developer, where if you've got a stream, where if you're going with a Flux-style architecture, you have a stream, the promise is that you will be able to just attach that stream as a property of the component, where Angular will, instead of checking on whether a particular property has changed, right, it now will wait for it will basically provide your property with a callback, and it's going to get called. And so this simplifies, it gives you massive boost in performance. Right? So the claims, the measurement from the Angular team is that you get, just even without sort of you doing a lot of work utilizing unidirectional data flow, you get 3 to 10 times improvement in speed. But if you actually make use of either unidirectional flow or of immutable objects, then you actually get quite a bit even more. And so now what this means is that Angular actually now gives you 3 different models for synchronization, right? So you have the traditional stateful model, right? So if you want to do that, you still can. Where Angular basically says, I I will have the view watch the state of your object. I'll keep checking it, and I will, whenever you modify, if you set a property to a view to something else inside of your controller, then inside of your component, then the view will update. Now, it does this in a much more componentized way, right? So you no longer have the ability of letting a component go ahead and actually watch an item, a property of your scope, right? But within the synchronization between view and the controller works. So the view and the sort of the implementation can still do that. And this is the one that gives you the sort of 3 to 10 improvement. Now, the reactive basically means that you are telling Angular that this is an event-driven property. It's not just a simple value. It's something that can accept a callback. And Angular then has much more opportunity for optimization because it doesn't need to keep checking whether this property changed. It just provides a callback. And then finally, mutable is basically a way for you to say this component, this particular property is never going to change. And then, again, the great advantage of that is that Angular then never has to check whether it has changed. And so, again, using the last two really is where it unlocks sort of massive performance improvements. And so finally, as all of this is componentized, there is no more digest cycle. I mean, the digest cycle in Angular 2 is just simply gone. Right? So there's nothing even quite equivalent. Now, what you lose with that is, maybe some of you might think this is a loss, is that you can no longer just go ahead and watch whatever you want. I mean, in fact, the idea of watching is also pretty much gone. Instead, you build components, your components interact using very clear interface. And then finally, controllers. So there's been a little bit of unclarity. You could say that Angular gets rid of controllers by essentially leaving only directives, but in some ways, it's almost the opposite. It's almost like as if Angular 2 basically makes everything into a controller. Because if you think about the way you define directives, so you can do this with link functions, right? Or you could do this by giving your directive a controller. So Angular 2 essentially strips down the most common type of component to pretty much just the most common type of directive, the component directive, to pretty much consist of nothing but what you would recognize as a controller. But it's no longer called a controller, it's called a component. But it basically, so the ideas of directives and controllers are merged. So what this means is that you no longer have the sort of the ng controller tag. Your controller now will basically, your controller is now called component and gets wrapped up in a little bit of a piece of metadata that specifies what is going to be the selector for that component. And it now externally, it acts much more like a directive or like a web component. Internally, it actually looks a lot more like a controller. So let me give you just a couple of examples quickly and illustrate some of the things that are happening on the view side. And one of the exciting things is that now, if you've looked at this before and maybe but not very carefully, you might have felt a little discouraged because you're like, what is that? This looks totally different from Angular 1. But the nice thing about this new syntax is that the new syntax is much, much more consistent. I mean, like, when you were learning Angular 1x, you had to learn dozens of different directives. In Angular, you can actually go really far by just learning those two pieces of syntax. So, and those two pieces of syntax is the brackets and the parentheses. So in Angular, in the sort of new Angular templates, what this markup means is that we have foo, which is some kind of component, right? And I'm leaving it as foo because it can actually be anything. It can be a component defined by Angular. It can be a native DOM element. It should work with external third-party web components. Also, I haven't tried it myself with web components, but the promise is that that would work as well. And then those components have public properties, right? And there's one type of property that can be set. There's some types of property that can be set, and there are other types of properties that are maybe not properties, but events. So in a way, every component logically has some properties that can be set from outside, and it generates certain events, right? So in this case, this component has a property bar that can be set and updated, and it has a property buzz, which is or not a property, but has buzz that is an event. This is the type of event that it generates. And you have two things that you can do. You could specify that you want to have bar updated whenever the value of this expression changes, or whenever this observable, if this is what it is, fires an event. And then you also can specify that if the buzz event happens, this is the function that needs to be called, right? Now, the nice thing about this is if you actually think about the Angular 1x design, we've learned obviously what each of the directive means, right? And what's the right way to use it, but you really have to actually learn it on every one by one directive, one by one, right? Because for some directives, the value is so for if you take, say, ngClick, the value of ngClick is the callback function. If you take ngShow, the value of ngShow is an expression that ends up controlling something, right? So in that sense, they behave differently. Here, and consequently, if you've got ng, you end up needing things like ngSource, ngClass, and so on. In this case, this is generic. If the component has a property bar, then you can tell Angular to set that property by using this notation. If the component emits an event of type buzz, then you could go ahead and subscribe to it. Right? It's really generic. And it's really up to the component what it defines. Those don't need to be defined by Angular. If you want to, yeah?
There's also a third type of deliverable, right?
Huh?
There's also a third type, which is a literal, without delivery.
Say it again?
There's a third type of attribute, which is a literal without any delivery.
Yes. You mean just by itself?
Yeah.
Well, that's a somewhat different thing. That's really more of a decorator, right? Oh, you're talking about the hash one that identifies.
No, not just a literal attribute. So, you know, P, Z, Z without the square bracket, 4 without the parentheses. If you just want to pass a literal as opposed to an expression or.
Oh, yes, you could do that. That's true. But I mean, in that sense, you are essentially bypassing Angular. So you don't need Angular for that, right? So no, that's true. I mean, if you have a property, you could just set that property to a value, and in that case, Angular doesn't really need to even do. Exactly. Yes, Angular doesn't need to do for you. But if you want Angular to actually actively update that property every time your expression changes, and this is your syntax that is meant to work across all properties, right? So now, just to give a somewhat more concrete example, so here's how, if we want to have a button that is disabled and handles a click, then this is how we would do this, right? So we have a button, it's supposed to say button at the bottom. The button has a property called disabled. So we are now basically saying, now again, we're not relying here on there being a directive called ng disabled, right? But a button has a property called disabled, so we can set it with square bracket notation, right? And button generates an event called click, so we can actually go ahead and subscribe to it, right? That's really all we do here. And then we could do this, but we can do this not, so this is button, but let's say that we have this amazing chart, and maybe an amazing chart is a web component, maybe an amazing chart is an Angular component, it kind of doesn't matter. The idea is that if amazing chart has a property called series, then we can have series update when my series property of the controller changes. And if it generates an event called drag, then we can subscribe to that event. So again, it's much, much more generic. So in that sense, much more powerful. And consequently, there's a whole bunch of directives that you will be able to just sort of forget about at this point because you don't need them anymore. So now the second thing and so this was the sort of the view synchronization part. Now let's talk a little bit about the other influence on Angular 2, which is classes and annotations. Okay? So in Angular, in JavaScript, we don't have classes natively in ES5. Now, arguably, I mean, some of us are not really huge fans of object-oriented programming anyway, but I mean, in those situations where you do want to use, where you would use a class where it were available in JavaScript, doing so is such a pain that you would probably end up deciding not to, right? So ES6 introduces the idea of class, so it makes it a lot easier to use classes in those cases where it makes sense. And I think that generally my sort of take on this is that when you're dealing with data transformations, you oftentimes do want to actually focus on functional solutions that really don't, that sort of pass things through. When you're modeling UI, sometimes it is a lot easier to model UI using object-oriented methods. So here's what an ES6 class looks like, where you basically, it's a lot more like class in any other language. There's a constructor, and then you set a name, you have a function set, method set name where you set your name, and then you can return it. So it's supposed to have this, because this I managed to give you in ES6 example. In pure JavaScript, you would need this. So in Angular 2, how do you end up using it? Well, first of all, your components, you can also think of them as controllers, are now classes. Now, this is already kind of the case in Angular 1x if you use controller as, right? So if you use controller as, your class function is really treated as a constructor. Angular will create it using this, it was using new, and then all of these sort of scope properties will actually be elements on properties of your this. But I mean, controller as is sort of a little bit lost inside Angular 1x. But with Angular 2, this is really going to be sort of the way to go, and the recommended solution for this is using ES6 classes. Now, the second thing is services are also classes. Now, I mean, this is part that, frankly, I'm still struggling a little bit about why services have to be classes, but they are. So that's two places in which Angular. So as a result, a lot of the things that you most commonly end up writing in Angular, components and services, are now both ES6 classes. So this streamlines your code a bit. So here's what a component would end up looking as a class. So let's say here we want to have a login form component that will have a method called validate. So we'll tell it which field we want to validate, and we'll provide the value, and it will update the input is valid based on this. And by the way, this is the kind of case where maintaining local state actually makes a lot of sense, right? Because we're not actually, this is not shared state with other components. This is state entirely internal to this component. And then we have a authenticate method that is actually going to do authentication, and the implementation is going to be TBD. So the way we would then end up using this in a template would be like this, right? So we will say that when we implement our login form, we will specify that we want to validate on key up. So every time key up event, and notice that we're not here relying on Angular having any special knowledge of key up. We're just relying on the fact that input field has a key up event. So we're saying it has a key up event, I want to subscribe to it. So every time the key up event gets fired, I want the validate function to be called. Now the second thing is I'm going to actually set my disabled property every time this expression is modified. And then finally, last thing that you might notice here is that we want to be able to refer to properties of different subcomponents, and so we do that using those hashes. So hash username allows us to then refer to username.value, and password.value we're utilizing the fact that we have hash password. Now, Angular 2 tries to stay really declarative, right? And so now one of the ways of making it more declarative, right, is that you need to actually attach some metadata to your components, right? Now in Angular 1, you achieve this with the directive definition object, right? So your directive definition object provides a bunch of metadata, and then you provide your directives controller. In Angular 2, there is a different solution, and that solution is annotation. Now, annotation is something that you could actually do in ES5 or ES6 by essentially attaching a property to your constructor that is an array that contains sort of objects that specify additional information about this constructor, right? So here's how Angular 2's annotations would look if you were to write them in plain JavaScript. So you would specify that you'll have a login form component, which you could, in this case, we're implementing it using class, but you could conceivably actually implement it today, something very similar, and we'll talk about this later, using just a plain JavaScript constructor. And then you have a property.annotate, and it has two objects. The first one is a component annotation, and the component annotation specifies things about what's going to be the selector for it. And then there is a view annotation which specifies the template, right? So in both cases, what we're really doing is that we're taking a JSON, essentially, expression of some of the configuration properties. We're wrapping it in an object, and we're attaching that object to the array of annotations, right? So this allows us to basically, instead of doing it Angular 1 style, where we return an object, and then part of that object is the controller, we essentially annotate the controller. We give Angular the controller, and that controller has a .annotate field that has all of the extra details. Now, Angular provides an alternative syntax for doing this, using sort of kind of Java-inspired annotations. And this looks like this, right? So essentially, adding add component with before an add view before class ends up having essentially identical effect to creating class and then calling login form component .annotate and specifying those two, creating those two items using component constructor and view constructor and putting them in an array. Now, this is something that Angular initially, the Angular team initially introduced in what they rolled out as TypeScript back in last fall, where they said they're going to go ahead and do their own, essentially, variation on JavaScript. In March, they announced that they're now going to just adopt TypeScript. And on return, the TypeScript team has agreed to implement the same annotation. So now TypeScript essentially is dead. TypeScript inherits TypeScript annotation. And finally, I'm putting them as ES7 with a star because there's a talk, and Angular team sort of stresses that they are fighting to get the same annotations actually included in ES7. We'll see that. I mean, that is yet to happen. So we probably don't want to call it and go ahead and sort of assume that this is going to be part of ES7, but there is a reasonable chance that those annotations will become standard eventually, in which case we will no longer be sort of dependent on TypeScript. Speaking of which, TypeScript. So now there's a couple of things. So TypeScript is, there's TypeScript specifically, but there's also the idea of typing, right? So a lot of people building larger systems have found that it does sometimes help to actually be able to make expectations about what types of arguments your functions get, and actually then fail early if you get something else. I mean, if your function expects a number and then you got a string, then all sorts of fun things can end up happening. There's a good chance that your function is going to eventually fail, but it may fail in a place where it's going to be really hard for you to actually understand what is going wrong. Right? If you get this failure early on, that could become potentially quite a bit simpler. So Angular started off by taking the idea of types from TypeScript, providing a somewhat different implementation, and this was TypeScript. So TypeScript was basically a variation on TypeScript's types plus annotation. What was announced then in March is that they've worked out their differences with TypeScript and agreed to actually adopt actual TypeScript. So Angular is kind of moving back to TypeScript, to really using TypeScript for types, and also then but in turn TypeScript is actually being modified to do typing the way Angular wanted it, and in particular to add annotations. Now, this ends up introducing one of the sort of big pains with using Angular 2 today. So Angular 2 today is sort of in between TypeScript and TypeScript, right? So what you will find is, as you actually start looking at Angular 2 today, that there's lots of examples. Chunks of Angular 2 are written in TypeScript. Chunks of Angular 2 are written in TypeScript. Examples you will find sometimes in one, sometimes in the other. It's fairly clear though that where they're going to is TypeScript, and so I think that it probably makes most sense for the rest of us to actually be sort of investing in TypeScript now. Now, it's worth mentioning that in a certain sense, use of TypeScript with Angular 2 is optional, and in fact, even ES6, use of ES6 is optional. You could use Angular 2 and write your code in ES5. Now, my feeling is that you can do that in about the same sense of can as you can drive a car without gasoline if you put a horse in front of it, right? But I mean, if you're going to be having your vehicle, if you have a horse-powered vehicle, then maybe the car is not going to be your best form of carriage, right? Maybe you should actually go ahead and get a proper carriage. So I have a feeling that it's going to be sort of a similar thing. I mean, if you're going to be writing Angular 2 using plain ES5 JavaScript, it can be done. You probably are not going to enjoy it, right? I think to get the biggest bang for the buck, you will need to at least be using ES6, and probably you would want to be using TypeScript. Now, how heavily you would be using TypeScript is a different question, right? So there's many parts of TypeScript that you really don't have to embrace as you even use Angular 2, but there are parts that Angular does end up embracing, and in particular, what it does end up making use of is using types for dependency injection. So here, what Angular does is a little bit of magic where it basically says, well, you want some service. So your constructor is expecting an argument some service, and you want it to be of type some service. And since I know that type service is an injectable service, I'm just going to go ahead and actually rely on that to provide it. Now, if you don't want to use that method, you will need to fetch services using an alternative method, using an actual injector object by making a call to get them, which works, but it is going to be a lot more work and somewhat not as nice. So I think this is going to end up being a big argument for going with TypeScript. So now, speaking of this, how do you declare a service to be injectable? Well, you do that in Angular with annotation. Again, remember that when you do @injectable, you put this in front of your service. Sorry, this is a slightly wrong example. This should be a class definition. When you do you put @injectable in front of your service class. What this really does is that it creates a new instance of injectable object and inserts it as an element in .annotate property of some service. So now modules. So that's another thing that Angular 1x kind of provided us with. But let's look at them. So Angular 1x module, well, ES6 itself, ES5 itself has no modules. Right? You could implement them in different ways, but there is no built-in module solution. So Angular does provide us with Angular 1 provides us with a module system, but it's fair to say that the module system that it provides really doesn't do much in terms of isolation. Right? In a sense, once your module is loaded, all of these services from each module that you loaded go into one big bucket of services and one big bucket of controllers, and they are no longer sort of distinguishable, right? So you cannot isolate, you cannot limit your elements to your services or your controllers to use just things within your module. So in that sense, there is not that much isolation. In fact, there's sort of an argument within the community of whether Angular modules are even worth it. Right? Some people prefer to write their Angular code where everything is just one module, because arguing that it's really going to ultimately end up in one bucket. Some people, we tend to go on the side of actually using smaller modules because it does end up paying off in testing, but in production it ends up not being all that different. Now, there is being an alternative to this. One is CommonJS. Now, CommonJS is nice because this is what's used by Node.js. It's very easy to use, but it doesn't work asynchronously. So that's a bit of a downer. The alternative has been AMD, illustrated by Require.js. It's asynchronous, but it's complicated. And finally, here is the kicker, is that neither of those actually solves Angular's one module problem, because Angular 1's module problem is actually really hard to solve, right? Because regardless of whether, so you could write your Angular code and actually package it into your CommonJS modules and then use something like Browserify, but then in the end, when those services are loaded, they're all going to end up in one bucket. So in a way, the modularization that you achieve with Angular, either whether you're using React.js or Require.js, or whether you're using something like Browserify, you don't actually end up with that much componentization. So now going forward, however, we now have better options. So ES6 now introduces the concept of a module, and it's a real module, and it's easy to use, which is awesome, and it's also synchronous when you want it to be. Right? So it sort of, in a way, gives us the best of CommonJS and AMD modules. And so Angular 2 is leveraging it. So I mean, Angular 2 is dropping its own module support use, and it's now just simply using Angular modules are now simply ES6 modules. And now you have a sort of a clear path going forward. And then finally, so if you want to be using today, this is just a tip, you would probably want to use System.js as the module loader for ES6 modules. And you could use them either for ES6 modules that are native, that to be compiled locally, or you could use it for to load ES6 modules that have been compiled using TypeScript into actual plain ES5. It's sort of similar in some ways to how Angular modules work, but they actually provide you with a bit more isolation. Now, one thing that's worth noting is, I mean, using TypeScript. So, I mean, I would recommend today playing, if you want to go play with it, is probably you want to use TypeScript. TypeScript does introduce a few quirks, at least as being my experience. Maybe just me not getting sufficiently used to TypeScript yet. In terms of there's a lot of demands that TypeScript makes of your code that you may not necessarily want to comply with, but and so you end up having to spend time kind of fixing your type definitions. But I think it looks to me all solvable. So and this is the way ES6 modules end up looking. So you, in the top of your file, you import something. So you will basically say, and this is how your almost every Angular file of yours is going to look like. So you're basically saying, let's import component and view. Remember, those are the component and view annotations from Angular 2. And then in the end, you will maybe export some service, or maybe you will export some controller, or maybe you will just go ahead and actually bootstrap your application. So now, any questions on the stuff that I've talked about before? If not, then the next thing I want to talk briefly about what it takes today to try using Angular 2, and then talk more about what should we all be doing in the sort of immediate future. Any questions so far? Okay, so let's talk briefly about trying Angular 2. So there are a couple of playground projects. I looked at a bunch of them, but I'll just recommend those two. So there are two of them, and this is, I said, unfortunately, the sort of Angular 2 is now at this crossroads between Tracer and TypeScript. So this is a great module that is a great playground project that has lots of that is fairly elaborate. It showcases lots of features. It uses Tracer. Now the downside of this is that Tracer is probably not what you're actually going to be using to write your ES6, write your Angular code, because Tracer is on its way out. And there's sort of subtle differences I find between Tracer and ES6 in terms of what some things seem to work with one and not with the other at the moment. And then the other example is the TS Quick Start. This is from Angular themselves. And this does use Tracer, so this is the easiest way for you to actually set it up so that you could use, you could have a simple project that uses Tracer. Unfortunately, that example is very bare bones. And again, I'm saying that what you can try doing is basically using one example and then having the two examples side by side and seeing which of the features from one you can carry over into the other. But sometimes there sort of seem to be subtle differences in terms of what works in one versus the other. It's worth also noting that you might have seen some sort of documentation out there that positions TypeScript as a superset of ES6. And now the catch is that this is true in theory, but it's not actually true in practice today, right? There is ES6 as defined by the spec. Tracer implements most of it, possibly all of it, because I haven't checked very recently. But I mean, it's pretty close to all of it. TypeScript doesn't. I mean, there are certain ES6 features that are just blatantly missing from TypeScript, and many of them, of the other ones, only got added very, very recently. So in that sense, you kind of have to keep in mind that they are not quite the same language. They're two compilers, but they're compilers for somewhat different specs. Now then, docs. So there is Angular.io is officially the place for you to go. Now, Angular team said that they're going to be watching the number of hits of Angular on this website and using that to decide whether people are excited about Angular 2. The odd thing is that up until recently there was no documentation there whatsoever. Now there is some, but again, it's fairly bare bones. You will maybe see, so you will see today there's an API is documented, but there's sort of no explanation. You'll just see the sort of the method signatures or class definitions. ngconf videos from last March, I would say probably one of the best sources on all of this. Right? So they're all on YouTube. You can watch all of them. It's about 2 days worth of content, but I think a lot of them are really worth it. And some of the talks there will actually give you a much longer and more detailed description of some of the things I've been saying here today on pretty much any topic. I mean, you want to learn more about TypeScript, there's a TypeScript talk. You want to learn more about dependency injection, there's the talk on that. You want to learn more about reactive approaches, there's like 5 different talks on this topic and so on. So this is a great source. And then finally, this, I made a bit.ly short link, it's bit.ly.ngdocs. And we'll post those slides somewhere. I'll post them on a link on the meetup page. But this really is the link to the to a Google Docs folder, a Google Drive folder that just has tons of design docs. I mean, this is really, if you want to deep dive and see what was done and why it was done, like all of the discussion is really, there's tons of documents there. You know, like if you want to see like why is Angular's 2 dependency injection looks the way it is, then there's document there that explains to you. Now, unfortunately, some of those documents, as they were written at the time before the decision was made, they don't necessarily reflect the final result, or at least a particular document might not. And then also, but there is also documents there that will actually document status, where you can see like minute meetings and so on. So there's lots of information. So I would say that right now you kind of end up being a little bit between this Angular.io that doesn't really have all that much information, and ng docs that actually has, and this Angular documentation in Google Docs that has tons. And then I would say that probably the YouTube videos is from last ngConf probably provides the biggest bang for the buck, so I highly recommend those. So now on to the question that what should we be doing now, right? So I mean, obviously, if there's a question of should you be adopting Angular 2, then the answer to this question for myself is no, not today. I think that, again, end of summer might be so I think if you're starting a project in end of summer, and this project is something that where you can actually, you're really thinking about the future more than you're thinking about immediate deliverables, then I think that at that point you might find that Angular 2 at that point will be a good, the right way to go. I mean, obviously this is a decision you'll need to make in August, because it's hard to predict now exactly how much we're going to have in terms of documentation and whatnot then. I'm guessing for the rest of us, for the rest of their projects, really probably more like end of the year is going to be the time when you're going to look and say, hey, I'm starting a new Angular project. I should probably just do it in Angular 2. No, so today you're working with either Angular 1.3 or Angular 1.4. What do you do? Well, there are a couple of things. So one is that you can get started today on ES6 and TypeScript, right? And this gives you a leg up in terms of transition to Angular 2. It also gives you tons of extra features. Now, the choice between ES6 and TypeScript is a little funny. So Babel and Tracer are the two probably most common ES6 transpilers. Both are really easy to get started with, right? So if you're looking for something where it's just easy, you're not going to experience any pain, then try Babel or Tracer. The thing is that TypeScript, however, is what you are probably going to end up using at the end of the day, right? So you kind of have to make a decision there. I would say, so I mean, if you try TypeScript, you found this still a bit too painful of an experience, maybe drop to Babel or Tracer. But again, keep in mind that in the long term, you're going to be using TypeScript. And I would suggest maybe not investing too heavily in Babel, in code that is compiled with Babel, because there are features that Babel and Tracer support that TypeScript does not, right? So if you're going to sort of start a project now using Babel or Tracer, you might find yourself in a situation in December where you want to switch to ES6 to Angular 2. You want to be using TypeScript, but you are using now features of ES6 which are not implemented in the TypeScript compiler. Now, hopefully by then TypeScript is going to actually catch up fully with ES6, but it's not the case today. And no, the other exciting thing about getting started on ES6 is that your ES5 is a subset of ES6. So your code, all of your code is already ES6, right? So you could actually set up your Babel transpiler and basically start converting all of your ES6 code that really is ES5 to ES5, and then start slowly. So in a sense, you don't need to go ahead and actually rewrite things. It's just that suddenly, once you set up the transpiler, you've got a whole bunch of options open to you, and you could start using them when it makes sense. You don't necessarily need to go ahead and rewrite your old code. And so now, in particular, what you would want, so again, there's lots of value that ES6 brings in general, but from the perspective of getting yourself closer to Angular 2, you would want to start writing your controllers and services as ES6 classes. So this is the way your controller might look in ES5, right? So now this is using controller as, and again, if you are not using controller as in Angular 1x, and forget about everything else I've been telling you, and just remember one thing: start using controller as tomorrow and stop using $scope. But so here we're using controller as. This is kind of probably what today is the conventional way of doing it. We provide a function here that is linked to Angular with dependency injection. This function is going to be We import this controller using controller as, which means that this function is going to be called with new. It's essentially used as a constructor by Angular. This is going to be the object that Angular is going to be synchronizing the view with. We start off by assigning it to VM, and then we're going to be using VM. Now, the reason we do this is because if we start using this, when we use this here, the effects are going to be different because this is no longer going to be the same this. So we use VM just to make sure that we're always pointing to the same project, and we define a method as VM.authenticate, and then which is within that method implementation, we then take our service and we actually do authentication, and then we follow up on the promise. So how would something like this look in ES6? Oh, VM stands for view model. Yes, view model, and this is really just an alias for this to make sure that, to guard ourselves against the fact that the meaning of this ends up changing. So this is what this is going to end up looking like if we're using ES6. So so first of all, actually, again, just this code would compile as would run as ES6, right? I mean, it's valid ES6 because ES5 is a subset of ES6. So, but what we now have with ES6, we also can define it as a class. So when we define it as a class, we'll define a constructor, and we will make our authenticate method an actual ES6 method. Classes in ES6 support class expressions, so you could, in the same way that you define functions and just return them and pass them as arguments, you could do the same thing in ES6 with a class. So in this case, we're going to define the class inline in the same way that we did before with a function. Okay? And so now the beautiful thing is that this will work. Okay? So if you take this and you compile it to ES5, it will give you code that is not going to look exactly like this, but it's going to give you code that's going to work with Angular 1.3 today. So you can start going in, you can start doing this today. Once you set up your transpilation, this becomes reality, and this works again with 1.3 without any problems. Now you can then you can do the same thing with modules, where we will then what I'm saying. So what we could also do is we could also use modules, right? So ES6 modules. So here we'll define our component in a module. We will then export it, and we'll have another module that imports login component and just puts it in the controller. Now, the upside of doing something like this is that we've now actually banished Angular 1 completely from our application. Right? There's really nothing. There's no Angular 1 really here, right? So consequently, when we later try to move this to Angular 2, we'll only need to add things. I mean, again, so this is the same. I mean, if you have a feeling of deja vu that this looks similar to the controller I showed you before, that's the point, right? This is a controller that looks just like an Angular 2 controller, and it should work in Angular 2. The only thing that you will need to do is you will need to add annotations to it in Angular 2. So this is how you will sort of import it. So you will organize your code as components, and no, sorry, what I want to stress. Now, with modules, one thing to keep in mind, though, again, that at the end of the day, with Angular 1x, those modules do end up not really giving you what you expect in terms of modularity, because you load your code, Angular code, through different modules, but at the end of the day, Angular is going to go ahead and insist on actually putting all of them together. Now, organizing your code as components. You can... The way you could do a step further in terms of making your code really look closer to Angular 2 and really be compatible with it is use isolated directives with controller as. And so in this case, and then if you actually write then your controller using an ES6 class, the way I showed you, you're now getting pretty close to what will work as an Angular 2 controller. So here is what a controller as directive would look like today if you're using ES5, right? So this is, again, using controller as, because that's really the way you should be doing those things. So we have our directive definition object. This directive definition object specifies the scope mapping. It then specifies that we're going to be using controller as and binding to controller. I skipped the template. We specify that this is using controller as, and the name, the way that the controller as is going to be referred to in the template is VM. And then finally, we provide a controller. Okay? And the controller here sets one property, and it then adds a method so that we will basically then have a name of the person, and then our template will specify a button. The button click will trigger VM.change, and then the name will change to a name specified as the next name property, right? So this is the controller. Now, how would this? So this is the controller as directive in ES5. So if we were to do this in, so now let's just look at the controller part of this, right? So this is what it looks like in ES5. If we were to convert it to ES6, we basically just switch to having a class. And the nice thing here is that this is basically an Angular 2 component without annotations. So if you later want to convert this into an Angular 2 component, what you will do is you will remove whatever came before it in your directive definition object, and you will add annotations before your class definition. And then you will get your Angular 2 component, and internally it actually has a good I mean, if it's at least if it's that simple, it's actually definitely going to work, right?
How you will write link function?
You don't. The short answer is that no, if you want to benefit from this, then you basically pretend that you never heard about link function, and you will strictly define your directives using controllers, and you will. And the important thing is that you will bring your controllers into your directives using controller as.
But what about transcript? You can do transcript the link, controller.
So again?
What about transcript, for example? Transcript is available on link, not on controller.
To be honest, I haven't thought about that particular piece too much. I can try to get back to you on this. Then the second thing to do is to consider the new router. No, the new router, I mean, I'm putting here consider because it's a little hard to say yet what's going to be really the end up being the value of it in the short term. So, I mean, Angular 1.4 introduced a new router. And obviously, Angular 1x had a router solution that most of us have found ourselves moving away from. We've been using at Rangle.io UI router on almost all projects for probably over a year by now, because just finding that for simple cases, UI router is just as simple, and then it gives you a lot more when you actually need it. Angular 1.4 introduced its own new router solution, and now the nice thing, the promise of it is that it will actually allow you down the line to use Angular 1x and Angular 2 state controllers side by side. Now, how valuable this practically is, I'm not at this point sure, but because if you're using UI router in a really simple way, then as long as your state controllers are written using ES6 modules, you will probably find yourself being able to reuse most of them later in Angular 2 without really having to. I mean, the amount of code that you'll need to modify is just the actual route definitions. On the other hand, if your UI router setup is very complicated, if you're really leveraging all of the different features of UI router, then you might find this transition potential to be a bit more also costly, right? So that's a somewhat more complicated thing to consider. So then the last thing is that you should consider Flux architecture. The unidirectional data flow can simplify your architecture, and it can really help you with performance. And in Angular 2 gives you a way of actually making use of it and using it to speed things up. So thank you very much. This is Angular 2.